Hello and welcome to the course Basics of Experimental Design for Cognitive Psychology. I am Dr. Ark Verma from the Department of Cognitive Science at IIT Kanpur. We are in week 6 of the course, and from this lecture onwards I am going to be talking about the methodologies that are typically used in experimental research. So, in today's lecture and the lecture for the next day, I will be talking about psychophysics. Now, what is psychophysics? As you can see, psychophysics is basically a combination of two words, psychology plus physics. Psychophysics basically involves the determination of the psychological reaction to physical events. Say for example, if there is a change in the light, how do we psychologically react to it? If there is a change in the loudness of the sound, how do we perceive it? How do we psychologically react to it? Measurement of the psychological reaction to whatever energy change is happening in the environment, that is basically what is the subject of psychophysics. Boring, for example, claims that the introduction of techniques to measure the relationship between internal impressions or psychological reactions and the external world, that is the physical world, basically marks the onset of scientific psychology. There is a very simple thought experiment that we do in a perception class, or I am sure in several philosophy classes as well, that suppose there is somebody, there is a jungle which is isolated and nobody is there, and somewhere in that jungle a tree falls, whether there will be a sound or not. Okay. Now, you can pause and think and come back and match your answers, but the answer to this will be that there will be no sound, because sound is basically the psychological or internal impression to the vibrations that might have been created with that tree falling. If there is no ear there to receive those vibrations, there is no ear on which the vibrations actually fall and they get registered as a sound, then there is no sound. All right. So, that basically this internal impression of whatever is happening in this outside world, whatever changes in the physical energy that are happening, that is called psychophysics. All right. So, the problem of psychophysics actually is slightly interesting, it is slightly paradoxical, because it asks us to objectify our subjective experience. Whatever say is happening in the outside world, say for example, there is a change in the lighting of this room. How do I perceive that change in the lighting of the room? Now, when I am saying perceiving, it is basically through my senses, basically my eyes in this case. I will register that the level of illumination in the room has changed. That will make me feel something, and I will say, oh, I am feeling that there is dark, it is dark outside. Obviously, the feeling of darkness will correspond to something that is happening in the physical world as well. When the light increases, I will perceive that the brightness is increasing. If the light decreases, I will perceive that the brightness is decreasing. This correspondence between what am I feeling inside and what is the physical change that is happening outside is basically what psychophysics is trying to measure. Okay. This subjective experience of whatever I am feeling inside, or the psychological impression that I am getting, is called sensation. All right. Now, there are two issues. How do we measure sensations? We cannot measure sensations, we cannot exactly measure how the neurons of the brain, for example, are reacting, because they are not open to overt measurement. They are basically can be measured by some kind of reporting, some kind of way that I will tell you that, oh, I am feeling that there is a considerable change in the illumination of the room. Suppose there are 5 bulbs that are switched on, and suddenly you switch off 3 bulbs and now only 2 bulbs are there. I am registering the change in the illumination, but how will you know that I am registering it unless I tell you? If I am not able to tell you, and this translation between what I am feeling and what I am telling, if that is not perfect, you will not be able to know what is really whether I felt that change in illumination or not. Okay. Also, something that is very interesting here is the internal judgments. How dark or how bright I am feeling this outside room to be is not directly corresponding, it is not directly identical to the amount of physical energy changes that are happening in the room and that are affecting my eyes or that are affecting my sensory apparatus. For example, it can happen that the light reduces from 100% to 10%. I am perceiving it as much more darker. If the light has changed just from 100% to 95%, I am perceiving no change in the light of the room or in the illumination of the room. So, the way the internal judgments happen, the way the internal impression happens of these physical changes is not a one-to-one basis, and it is not absolutely identical. So, identical changes in physical energy will not cause identical changes in the psychological perception of these changes. Let us take an example. For example, you have this amplifier or radio dial. Suppose you are in your car and you are trying to change the volume of the music system of the car. Now, if you are trying to change the volume of the music system of your car, remember that it does not bear a one-to-one relation between the movements of the dial. Nowadays, you can have a dial or a remote, and the increases in physical energy that your sound equipment is producing. For example, more importantly, what needs to happen here is that the dial will have had to be calibrated so that its movements increase intensity proportional to increments in loudness. Loudness is what you are perceiving. Loudness is not the property of the music system. The property of the music system is the increase in energy. How does that increase in energy correspond to your perception of loudness? That basically is calibrated, and that is what you are trying to measure. For example, doubling the volume level on the dial will probably have had to increase the physical energy about 10 times. So, if the output of the sound system is increased 10 times, you might only perceive that okay, the volume has just multiplied by 2, it has just doubled. Alright. So, that is how this relationship really works. Also, there is something interesting, that the psychophysical relations between the stimulus and the judgment depend on the particular sensory modality that is being tested. For example, the way the sensory modality of vision works may be different from the sensory modality of audition, may be different from the tactile sensory modality where you are manipulating touch, or the olfactory or the gustatory modality. Okay. For example, pain judgments in response to increases in electrical intensity of shocks applied to the skin can actually grow much more rapidly than loudness judgments increase in response to increases in sound energy. So, as I am increasing, let us say, the electrical shock by 5% and then 10% and then 15%, maybe I am experiencing that my pain is increasing exponentially. On this case, in terms of the sound, when I am increasing the energy by 10 times and by 100 times and by 1000 times, for me only then it is going to double. Alright. So, for one shock to be judged to be twice as painful as another, the intensity of the shock will need to have increased by about 1/3. So, there is a larger increase that is required there. Actually, there is a smaller increase that is required in the shock, and we feel it that it has happened much more. Okay. Psychophysics tries to solve this problem by closely linking perceptual experience with physical stimuli. The idea is that you use the physical stimulus as the reference system. So, you basically calibrate your experience to certain levels of the physical stimulus. The stimulus characteristics then are carefully varied, manipulated up and down, and observers are asked to report their perception. Say for example, if you are playing with, let us say, sound at this point, I will go with the level that has 0 sound, and I will ask you to report it, and then I will increase it in some steps, and then I will ask the person to report how they are feeling. And I will try and develop, I will try and find out a relationship between how am I increasing the energy in the sound instrument and how the person's experience of sound is increasing. Once I have deciphered that relationship, I will be able to estimate what kinds of changes in physical energy here will lead to what kind of changes in the perception of loudness. So, the idea in psychophysics is to formulate a question that is very precise and that is very simple and that basically obtains a convincing yes no kind of an answer without having a lot of thought going in. So, the simplest question can be, can you hear the tone at this point or not? You will say yes when you can barely detect the tone. Can you tell me which tone is being played? You will say yes only when you have recognized, oh, this is the song that is being played. Alright. Now, one of the things that sort of is an extraneous variable, if I may use the word from the ongoing discussion, in terms of how we perceive these signals, is the noise in the environment. So, for example, you are trying to play me a sound and you are trying to check whether I am hearing that sound or not, can be affected by both external noise, there are other sounds playing in the environment, and internal noise, my mind is moving here and there and I am thinking about any number of things. So, there is obviously always going to be noise with whatever we are trying to measure, happens in psychophysics as well. Now, in such cases the task is one of discrimination of stimulus. So, basically what you are trying to do when you are trying to detect a particular stimulus is to discriminate the stimulus from the noise, discriminate this particular signal from the ambient noise in the environment, and this task is always performed under uncertainty, because obviously there is a degree of error in the mental sort of measurement also in the way your neurons are firing and so on. So, there is systematic error as well as there is random error possible in both kinds of measurements. So, how do you determine whether we can detect a signal at a given point or we can discriminate a signal from noise? That is basically what is done in psychophysics, and that is what we are trying to do here. The first and the most important concept here is this concept of threshold. For us to be able to detect any physical stimulus, the stimulus has to be above a certain threshold. So, the idea is mental events will have to be stronger than some critical amount in order to be consciously experienced. So, if the neurons of my brain are firing in response to the changes in the sound and they are, say for example, maybe they start firing much earlier than when they are in my conscious experience, but for me to be able to report, they will have to be happening at a particular threshold where I can consciously experience that, oh, I am detecting something. Some kind of processing probably is still happening, but I will only be able to report once I have consciously detected that particular sound that let us say you are trying to play. Now, the most basic function of any sensory modality or any sensory system that we have our 5 senses, is to detect energy changes or detect changes of energy in the environment. So, how do we hear sound? There is changes in this vibrations in the air, changes in the air molecules energy that we register in the tympanic membrane of the ear, and then we transduce that back into listening whatever is there. So, this energy in some cases can consist of chemical agents. So, as in for example, taste or smell, where there are these particular receptors, electromagnetic, vision, mechanical, that happens in audition, proprioception, touch or thermal stimulation. So, all of these things that we experience through our senses are actually changes in the physical energy of stimuli in the environment. So, that is something that is very basic. Now, in order to be noticed, in order for us to be able to notice a change in light, a change in sound, so on, the stimulus has to contain at least a certain level of energy. If it is under that level of energy, if it is under that threshold, we will not be able to detect that change. Okay. So, this minimal amount of energy that is there, for us to be able to register that sound or register that amount of light is called absolute threshold. Okay. According to Fechner, this is basically sound makes itself felt when it lifts its sensation over the threshold of consciousness. Let us try and understand this. This is, for example, the proportion of responses that are detected. So, around 0.5, and stimulus intensity is increasing here in steps. At the level of 0.5, when you are till you are not sure, and when it crosses this 0.5 and you can say, oh, yes, I detect that particular sound, that level is called the absolute threshold. So, this is the level of stimulus intensity that must be there in that stimulus, be it sound, be it light, for you to be able to detect it over a level of chance. See, if there is a if there is a two choice decision, yes versus no, then obviously it has to be above chance for you to be able to say, oh, I detected it any number of times out of 10. So, here you can see the stimulus intensity is your absolute threshold, let us say number 5, after which you have been consistently able to say that, oh, I detected the stimulus. So, this becomes an example of absolute threshold. Now, the absolute threshold therefore can be the intensity of the stimulus which the observer can barely detect, can basically know, oh, okay, this is happening. On the other hand, there is also the concept of what is called difference threshold. So, the difference threshold basically refers to the minimum intensity by which a variable comparison stimulus, there is a comparison stimulus, must deviate from a certain standard stimulus to produce a perceptual difference. Say for example, I have given you two balls to hold and I am asking which one is heavier. Now, suppose this is 1 kilogram and this is 1.05 kilogram. If this difference of 0.05 is able to be registered, I can register this difference of 0.05 grams, only then that 0.05 gram will be treated as a difference threshold. Suppose I cannot detect the difference between, let us say this is 1, this is 1.10 kilograms, at least a 100 gram difference that is. Unless that is achieved, I will not be able to detect the difference that which is heavier. So, then that will become my difference threshold. So, here you can see here is your reference stimulus and here is your comparison stimulus. The difference at which you can actually answer that, oh, greater, this one is greater, that difference is referred to as the difference threshold or the difference limit. Now, how do we determine threshold? So, how do we, so psychophysics is basically all about this. How do we quantify these subjective experiences? Now, one of the methods to determine threshold is called the method of adjustment. What do we do? The simplest and the quickest way to determine absolute and difference thresholds is that you let the subject adjust the stimulus intensity unless it is just noticed or until it becomes just noticeable. So, that basically will measure the absolute threshold of a particular sensory modality, or it appears to be just noticeably different from a standard stimulus. Say for example, you have one and you have the other and you are basically adjusting it to a level that you can just 1.05 or 1.01 or 1.02, what is the level at which you can just tell that this one is heavier than the other. So, how do we do it? Let us go into the steps. The observer is typically provided with a control of some sort that can be used to adjust, let us say, the intensity of the sound until it becomes just audible. So, you start from 0 and you basically give the the participant, let us say, a remote or a dial that is used to increase sound. You would set it all the way down to 0 and then you ask the participant to increase it in particular steps till it becomes detectable, till the participant can hear, oh, this is where I can hear it. This intensity is recorded to provide an estimate of the observer's threshold, the intensity at which it becomes just detectable. Alternatively, what can happen is that the observer can adjust the sound from being very clearly audible. So, you start at the top and you start reducing it and you reduce it to the point where it goes out of detection range. So, in one case you start from the bottom and match around when this is detected, and the other case you start from very well audible to and you start reducing it to the extent where it becomes just not audible. So, at that level somewhere these two thresholds will coincide. Okay. Typically, these two kinds of adjustments are alternated several times and the results are typically averaged to get a estimate of the threshold. Okay. So, this is called method of adjustment. There is another method that we can help us determine absolute threshold, which is called the method of limits. Now, a major difference between the method of adjustment and method of limits is that here you are not allowing the observer to control the stimulus directly, it is the experimenter who is adjusting the levels and the experimenter is doing it in discrete steps. So, you increase by 5, another 5, another 5, another 5, and then you basically see where the participant is going to be able to detect the absolute threshold or is going to be able to register the difference, which is called the difference threshold. So, what happens in the method of limits? A single stimulus, let us say a single light, is changed in intensity in successive discrete steps and the observer's response to each of these stimulus presentation is recorded. Increase it to 5, did you detect it? Yes, no. 10, did you detect it? Yes, no. 15, did you detect it? Yes, no, and so on. So, here just as an example, one can start when the stimulus is too weak to be detected and then increase the intensity in discrete steps. So, let us say every 5 or every 10 or every 20, whatever the case may be, till the stimulus is still visible. Okay. So, it becomes visible, sorry. Or you can start from a clearly visible stimulus and you can start reducing it in discrete steps. So, let us say it is at 100 particular 100 units, you start going by 95, 90, 85, 80, 75, 70 and so on. Okay. So, the last one is seen and the last seen and the first not seen, that becomes your interval of uncertainty, which you will measure several times and then you will average out to figure out the absolute threshold. Okay. Look at this here. So, in one case you are going in a way that you are basically starting from 200, reducing it by 20. So, here you get at the level of 180. So, this is the difference of 20. Here you start with it is not visible and you increase and at around 140 you get it visible. The third trial you again start with something that is clearly visible and go till it is not visible, and the other trial you also start with when it is not visible to it is visible, and then you get these values. So, here it became the average of 180 is 90. Here it is 140 and 120, so it is 130. Here it is happening at again 140 and 120 is again 130, and here it is happening between let us say 100 and 120. So, the average is 110. You take the average of these measurements, that becomes the mean absolute threshold. Now, you can use the same method of limits to determine the difference threshold as well. For example, difference threshold, as we have said, it is based on relative judgments in which a constant unchanging comparison stimulus. So, the first stimulus or the standard stimulus will be unchanging. So, that is let us say 1 kilogram. Now, you have another stimulus whose weight you will vary. So, for example, you will start with 1.01, 1.02, 1.03, 1.05 and so on, and then at the point where you can actually say, oh, I detect that this one is heavier, that will become the difference threshold. You can start with, on the other hand, again with something that, oh, this is 1 kg and this is 1.5 kgs, and then you can start reducing to the point when it becomes, oh, it is now almost the same. So, it is the same that you have done. The question that you are asking is again going to be very simple. You can ask the question that, oh, how different must the two stimuli be before they can be reliably distinguished? The traditional way again is to ask the observer to lift pairs of weights, one is constant, the other is changing, this one you keep changing, and to judge if the new weight is heavier or lighter or equal to the standard weight. Okay. The method is very similar to the last instance. You can start from a weight which feels clearly heavier and go till it becomes almost equivalent, or you can start with a weight which is clearly lighter and go till it becomes almost equal. The upper threshold is the average point at which the observer changes from heavier to equal. The lower threshold is the average point at which the observer changes from equal to lighter. This basically is called the interval of uncertainty, and the mean of this upper and lower thresholds is called the point of subjective equality. So, here you can see that. So, let us say the standard stimulus is something and you started with the one which is heavier. So, 350 feels heavier, 40 feels heavier, 30 feels heavier, 20 feels heavier, 310 feels equal. So, you basically take the average of 20 and 10, it becomes 315. In the other one you basically and you can take this lower value also 290 and 280, where it becomes from equal to lighter. So, actually here it will be this level. Similarly, you start from when it is considerably lighter to when it becomes equal. So, you have this mean of 315, the upper threshold is 315 and the lower threshold is 295 when it becomes lighter to equal. So, there are two thresholds possible, heavier to equal and lighter to equal, these two thresholds. So, the upper threshold is heavier to equal, the lower threshold is equal to lighter. You do that across 4 measurements, you get the upper threshold 4 times, you get the lower threshold 4 times, you make the subtractions and you basically get the interval of uncertainty to be around 20 grams. Okay. Here you can see that 310 minus 290 is around 20 grams difference is needed. So, if the two stimuli are different by at least 20 grams, only then the participant will be able to detect that one is heavier or lighter. So, that is all about the initial instance into psychophysics. We will continue our discussion on psychophysics and signal detection in the next lecture. Thank you.